Okay. Hello everyone, welcome again. I'm glad that you came. Maybe there's not that many people that it used to be, but I'm very glad that you're here, and I hope that thanks to the fact that there's only 8 of us at Zoom at the moment, we'll get to conversate, not only like perceived lecture. We'll start in a second. Let me just share my screen to you on Zoom. Okay, it should be visible, is it? Is it visible on YouTube as well? I think it should be, but it's always good to ensure. So today I'm managing this Zoom thing by myself for the first time, and I'm not sure if everything's alright, if people will be able to join us in the meantime, like not in meantime, but during the meeting. I hope yes, but we'll see. I'll keep the list of participants opened in case it doesn't work as I wanted to. One more thing, I need to open Zoom chat. Great. Sorry. Okay. It looks like everything's okay. So yeah, let me just change the scene and we will start. Now the camera froze there, just a second. Okay, great. So today we're going to do a like showcase of the capabilities of Pandas library in Python. We'll do that by analyzing a dataset from Kaggle, which is about Kickstarter projects. Maybe I'll just show you the page of this dataset so that we all know what we're dealing with. So if you don't know what Kickstarter is, it's just a page where startups can gather funds for their companies that they'd like to create. They are usually very fun and innovative ideas there. So I think that it will be great dataset to analyze. Okay, so I'll paste a link to it on both a YouTube chat and Zoom, so that you can download it for yourself if you'd like to follow me along while I analyze it. I'll also show you how to use Kaggle API to download it. We don't have to do it manually. Oh, excuse me. So to get the Kaggle API, you just have to type. Type pip free or pip if you're on Windows. Install Kaggle. As you can see, I have already installed it. And after you install it, you should be able to type in the Kaggle command in your terminal. Just type in Kaggle version to make sure that it's installed. And Kaggle has few commands associated with it, with which we can download datasets. I actually don't remember them, and it's a good practice to follow to follow the guidance of documentation. So we'll Google Kaggle API doc to get the Kaggle official documentation of the API. I already have my API token from my Kaggle account linked. So if you don't have it, it's probably better if you just download the data straight from the site. So as you can see, interact with datasets. We can use this command to view datasets that follow center keyword. So I'll use this command. It didn't copy. Okay, and yeah, I'll type kickstarter. And as you can see, we have a list of datasets that have kickstarter keyword in them. So the one that we'll use is this chemical kickstarter projects. And now to download the dataset, let's see. We have to type Kaggle download the dataset download slash d not slash but this sign, I don't know what it's called, and then paste in this maybe not paste in yeah, we can paste it the name of this dataset, the first column of the thing that the other list command returned. So yeah, if we do that, the dataset will start to download. In the meantime, I'll create a new Jupyter notebook. If you use Visual Studio Code, you can just press F1 and type in Jupyter, and one of these options should be create new blank Jupyter notebook. So I'll do just that. It's taking a while. I'm not where I'm supposed to be. Just a second. Let me close that. Do you have any questions about the Kaggle dataset or about the data itself? We'll explore it in a second, but while we all download it or not, I don't know if you want it. I want to do it that way. Yeah, once again, I'll open folder. Yeah, and once again I click F1 and type Jupyter, create blank Jupyter notebook. In the meantime, our dataset was downloaded. I downloaded to not to the place where I wanted it to be, so I'll just move it manually. It will be faster, I think. So the dataset, if you download it with the Kaggle API, it should come in a zip folder. And if you unpack it, there should be our data. If you don't know what Kaggle is, it's a great place to learn data science. There are some short courses there, as well as tons of datasets and tons of solutions, or different analysis, not solutions, different analysis of these datasets. Okay, let me just move the data here and unpack it. You can't see what I'm doing, but I'm just unzipping this zip that Kaggle downloaded for me. Okay, I have my data in the right directory. And the Jupyter notebook was created. Let's name it Kickstarter. That's enough. Oh, did it save? No, it doesn't appear to be saved. Oh, it is there. Okay. Great. I'm using Visual Studio pre-release version, which brings us improvement to the Jupyter, I don't know, extension or whatever it is, so that it looks a little different and works a lot faster. Yeah. As you can see, we have two files downloaded from the Kaggle. The one that we want to use is this second one, and we can import our libraries. If you don't have these libraries, again, just like with the Kaggle API, type in pip install and then the name of the library. Today we'll only need Pandas and Numpy. See, leave me alone. So yeah, I'll load in these two libraries. My kernel is started and libraries are loaded, so we can start our analysis. The first thing that we would like to do is to load our data, because if we don't load it, we can't work with it. So to load our data, Pandas, maybe I should start with what Pandas and Numpy are. So Pandas is a library that allows us to manipulate and analyze and even to a certain extent visualize our data, and Numpy is a library that introduces tensor calculations to Python, so that it works a lot faster. It has its own array class instead of Python's regular lists, and lots of different mathematical operations that speed up Python through just better implementation of these things. And Pandas is built on top of Numpy, so the creators of Pandas use Numpy in their in Pandas to build Pandas. So we'll need a variable name. Let's call it KS as Kickstarter, and our first Pandas function will be to read CSV. It will be read CSV. CSV is a shortcut acronym for comma separated values. If we open this one of these files, you can see that these are comma separated values. That's where the name comes from, and as an argument to this function, we'll pass the name of the directory where our data is. In our case, it is the same. In my case, it is the same library, the same directory. So. Yeah, that's the name of the file, and I ran this and everything went all right. So we can now view our dataset by just typing in KS, the name of the variable where I assigned it to. And as you can see, we have around 10 or so columns with different values in them. So the first thing that I always like to do at the start of analysis is to display info proper info function method on the pandas data frame. Okay, so there's one more thing that I'd like to say before we begin. Pandas stores data in, let's say, the same way as, for example, Excel sheet. So the class is called data frame, and each row and each column is a pandas series. If we check the type of this data, as you can see, it's pandas data frame, and and each row and each column of the data frame is a pandas series. These two classes have most of the methods the same, but some are different. So you can perform certain actions on the whole dataset, but you can't perform them on the series, and vice versa. But most of the commands are the same. So let's call ks.info, and as you can see, it displays a short info about this data frame. We have 14 columns and over 300,000 rows in the data set. These are different data types. I can see that they are not correct. We'll change them. That's just the way it came from the Kaggle, or just the way that Pandas loaded it. We'll need to change them to make our analysis easier. So the other command that I like to learn use at the beginning is display. Not display, sorry, describe. And describe gives us like a simple statistics about this data. Let me just change this print command to display. I think it is a command from IPython, or just that comes with, it probably comes with IPython. It just prints the results in a prettier way. As you can see, it did. What I like to do with this Scribe method, I like to transpose it by typing .t on pandas series or Numpy array, or probably most of the classes from these two libraries. .t transposes this output. So as you can see, now we have columns on the left. It prints out the count, mean, standard deviation, percentiles, minimum and maximum. That's what .describe does. I've got to ask you, is there anyone who's not familiar with Pandas at all, or Python? Okay. Okay, great. So just feel free to turn on your microphones at any time, or just type some questions in the chat if anything is not clear. Is everything clear to this point? This meeting should be completely beginners friendly, so if at any point I don't explain anything, something efficient enough, just let me know. I can see that we have some person on the YouTube as well. You can stay on YouTube or just come to the Zoom meeting if you like. Then you'll have the opportunity to turn on your microphone and ask a question this way. Great, okay, so I can see that most of us are not familiar with Pandas. That's great. Yeah, let's continue. So the first thing that I'd like to do with this dataset is to change these data types, because as you can see, not all the columns that are supposed to be displayed in this .describe method are described because they are not of an correct type. Let me give you an example. I don't know. It looks like every every column that is supposed to be an integer or a float is correct, but instead of, for example, in deadline, instead of a date object, we have a object, just objects everywhere. Objects usually mean strings. Is it possible to change basic directory with Python command? Do you mean like change the directory you are in currently? So once I write, is it? No, it goes, once you type in read CSV, it goes into the same directory where you are. I am in the directory called kickstarter, so if I don't specify anything here, it'll just search for my directory where the Jupyter notebook is. And if you'd like to specify some other directory, you can do it right here. For example, C blah blah blah, yeah, yada yada yada. You can specify a full path. Furthermore, to read CSV, you can specify you can give a link to a dataset on the internet. Kaggle doesn't share their datasets in a raw format, but there are lots of sites that does, and then you have to open the raw format of this data. There should be a link to raw format next to the link to the data. And if you paste in this link there, the data should load as well. Read CSV is not the only function that you can read data with. It's only one of many. So there's read Excel and many more. If you don't know how to read some specific type of data, just Google it. Google is like the most powerful tool of data scientists. So if we don't know how to read data from Excel format, you can type in Excel pandas load or something like that, and first thing that pops up is pandas documentation. As you can see, pandas has a function read Excel. Read Excel works and has the same attributes as read CSV, I suppose. Probably most of them are the same. And yeah, there's like lots of different arguments to each of these pandas functions. We won't go through all of them because we would spend 20 hours here instead of 2 or so. So yeah, everything that I say is like very brief, and you should explore the pandas library by yourself, or read the documentation. And the main thing that I'd like you to take out of this meeting is to know what is pandas capable of, and it's way easier to Google something when you know that it is possible, right? Yeah, sure. You can always import OS library, pandas standard library. And in Jupyter, if you type an exclamation mark before first, and then a command like pwd, it will execute this command in the command line, not in the Jupyter. So I can, for example, type in ls as well. If you're not familiar with that, that's okay. We should get going. So I've prepared an array with correct data types that this data frame is supposed to have. We'll name it correct, for example. Yeah, so we won't go through it because it's kind of self-explanatory. We use the only thing that I mentioned is that we use Numpy data types because Pandas is built on Numpy. But you don't have to do it. We can use regular Python ints as well. But this should probably work more seamlessly. I don't know. It's just what Pandas does by default as well. So we'll do the same. And what I would like to do now is I'd like to create a dictionary, Python dictionary that contains the name of the column as a key and these values from this from our array in the other one. So this is how we do it, and oopsie, and that's at the beginning we should always copy our data set to another variable. That's just a good practice. The data we'll use df as the name, so maybe let's change it as well in here. df is like the default name that we use to name data frames. And that's basically what I've done with this 3 or 4 lines here. So I iterated through data df.columns. df.columns is another like property of our data frame that prints out all the names of columns in an array. As you can not see, as you can see, these are the same names as names of the columns under the df.columns command. So I've created a dictionary, each column with the correct data type, and now we can use a another method of a data frame as type, and we can now give this dictionary to this function, and it will change all the data types based on the column names to another one. So after I execute it, we can also it will be changed, and we can also use d types to see what data types our data frame has, and as you can see, we managed to change those to the data types that we want. Another like very important method of Pandas is df.head. By default, it displays first 5 rows of the data frame, but we can specify any number in the head function, and you will print out that many rows. And there's also tail, and as you can see, it does exactly the same, but from the end of the data frame. What we'll do next is we will clean up our data frame a little bit. As you can see, we have like ID column, for example, which is basically useless for us. So yeah, let's get rid of it. To get rid of it, we can use the drop method, and as the first argument, I'll specify the column name. The second argument will be axis. Axis argument specifies whether we want to drop a column or a row. Row is 0 and column is 1, so I'll use 1 because we want to drop a column. And another argument of this function is in place. What this does, it's only that we don't have to assign it to data frame variable again. If I don't specify it, as you can see, the ID column disappeared, but if I print what's inside df, the ID column is still there. But if I specify the in place argument to true, then as you can see in the data df, there is no more this ID column. Oh, now it raised an error because I executed this code again, and ID column is already gone. Okay, let's see how many missing values do we have in our data frame. So to do so, if you don't know what missing values are, these are just the values that that were not specified by the person creating this dataset, or were not measured by a device measuring our data or whatever. Just missing values. To check how missing values with pandas, there is a function isNA. And as you can see, it prints false if the value is there, and true if it's null. In this format, we can't see anything because there's 400,000 rows in this dataset. So what we'll do is we'll call another function that pandas has, sum, and we'll sum up. If you sum up true and false, trues are ones and false are zeros, so we get like the result that we are looking for. And as you can see, in the US pledged, there's 4,000 missing values and 4 missing values in the name column. Let's firstly deal with these names. There's like many ways that we can deal with missing values. It depends on the type of the missing value as well. If these are strings, we can't really do much about that because we won't fill this string. We can just ignore it or delete these rows. And as it comes to other data types, for example, numbers, integers or floats, what we can do is we can fill these numbers based on like columns that are near it, or we can fill these values with some machine learning algorithm that would predict what these values could be, or we can just drop them or fill with a value that we think would be well there. It depends on the data frame. Let's now see how we can get to a specific column and row through pandas. So if we specify just if we can use, do it the same way we would do with Python list, so we can or dictionary, we can just do it like that, and as you can see, it returns only the names column. Or we can use the ilog and lock methods. These methods allow us to easily manipulate both rows and columns. First, we specify how many rows we'd like. This sign allows us to load all of them, and yeah, that gives us the same result, but there are two ways to do that in Python. Yeah, there's another way. We can just type dot name, and it will return us the same result. And the difference between ilog and lock is that ilog accepts integers instead of strings. So if I type in name here, it throws us an error, but if I specify an integer like 0, it gives us the same result. So what we want to do is want to check those values that are null in this in the name column. So we'll look for a data frame. Maybe let's show this first. Name.isNA, and as you can see, it only gives us this row, and again false and true values. So what we want is true values, and we want to show the whole, like we want to show them in the data frame, so we can do it like that. So from data frame, select those values that have a name, column, null. What this does, it shows us these 4 rows that are missing in our data. These are the so we can do many things with these missing values. There is only 4 of them, and our dataset is big, so I'll just remove them. To do so, we can use a drop method again. Let me do it this way. Oh no, maybe let's first assign to a variable indexes of these values, because now we'll drop it by a row. Yeah, let's call it int, and we get indexes by just typing index on them. So as you can see in int, now we have these indexes of these missing values. What index is just like the number that is assigned to each rows are enumerated, and these are called indexes. And now we want to drop these indexes. And we don't have to specify axis again, because as in default it is 0, but just to like not confuse you, I will specify it to 0, and again we'll do it in place. Oh, not pandas, but data frame. We want to do it on the data frame. And if we do this again, show the value, maybe not. Let's call this again, this command again, to see if we did it correctly. And as you can see, there is no null values in the name column anymore. So now let's deal with this USD pledged. I read earlier on the Kickstarter on the documentation to this data frame that USD pledged are just values that were given by a Kaggle probably from the API, and USD pledged real are the values that somebody filled to give the real values of pledged amount of money. I didn't explain each of these column names because I feel like they're self-explanatory. If you like, pledged means that collected, yeah, let's say. State is the state of this project, whether it failed, it was cancelled, or it succeeded, or something else. We'll explore it in a second. The goal, and yeah, I think that these column names are self-explanatory. So let's copy this again and just change name to so as you can see, there is no this sign here, so we can't use we can't access this column through dot. In this case we have to use this method. So let's see what are these missing USD. These are the missing values. As you can see in the USD pledged, we have nones. What we'll do is we'll get rid of this column. So because as I said, these are not the correct numbers. USD pledged real are the correct numbers. So let's just call df.drop USD pledged axis 1 and in place true. And now we don't have this column anymore. And if we call this command again, we can see that we have no longer missing values in our dataset. And now we have 13 columns, not 14. But what we'll do now is we'll deal with these dates. There is a deadline column and launched column. This doesn't tell us much about this data. So what we'll do is we'll extract some information from these two columns, and we'd like to extract for how many hours has it been online on the page, this certain project. So to achieve that, we just have to subtract the deadline from from launch subtract the deadline. In Pandas we can just do it in this simple way. So we can just specify the column deadline and subtract column launch from it. And Pandas can do it easily because we changed the type to datetime, and it knows how to operate different mathematical operations between two datetime objects. If we subtract it, launch. I can't. Oh, it's launched. Yeah, okay. And now let's view days. And as you can see, the data, these pandas and these datetime objects are so smart that it even gives us how many days and hours has it been online. But this is not a numerical form we can use. So what we will do is we'll transform it. Let's take a closer look to this object. Now, so days is a column, and if I indexed it with 0, we'll get a row because there's no more columns. I can, we can. Maybe I should show you. We can do the same from here. We can specify deadline and take the first row from it. It returns in the same way. Or we can do this with iloc method, for example, and take from third to sixth row from third column, and it does the same. Yeah, that's how you access different values of our data frame. So let's create a new column in our data frame. How we do it? Just by giving a name of column that it doesn't already have. Let's call this column hours active, and we would like to assign days to it, but as you can see now we have a new column in data frame. Let's show the head of the data frame, and as you can see at the end we have hours active. This is the result of this command. So if we take a look at this hours active column, and let's take first value, it is time data. You can Google it in documentation, but I know that it has a method days, and it just returns 58, and it also has seconds, and it returns the number of seconds. It also has milliseconds, if I'm not mistaken. But it doesn't add up those two numbers. So to extract just the number of seconds it has been online, we have to first take days, then multiply it by correct number to get seconds, and then add these seconds to it. So if we want hours active, we have to do just that. Just 1 second. Okay, and so we need to perform some mathematical operation on each row of this data. And Pandas has a convenient way of doing so, a method apply. So if we print type of days, you can see it's a Pandas series, as I told you. The whole thing is data frame, and each row and each column is a Pandas series. And a series has, as well as the data frame, has the method apply. So we can apply, we can use this method, and it expects a function as an argument to this function. It expects a function here, and in Python we have Lambda functions, and this is a great use of Lambda functions. We don't have to specify a whole function. We can, because we will do like easy operations, only one line, so we can do it in more Pythonic way by using Lambda functions. It takes an x as an argument. X is each value in this days series, and what we want to do is we want to extract only hours. So to do so, we have to multiply, we have to divide, now I can do this x dot seconds, because x is each value in each row of this data frame. So as you remember, it was timestamp or something like that, this object, and I showed you that it has a method seconds. So I take seconds, and to convert seconds into hours, we have to divide it by 360, right? And then we have to deal with this days part of this object as well. So to change days into hours, we have to just multiply these days by 24, because there's 24 hours in a day. I hope that I'm right. Let's see what it returns us. Oh, sorry. What it returns us. It takes a second to perform this operation on each of the rows. And as you can see, it applied this function to each row of our series, days series, so that we get the number of hours in each of the rows by 300. Are you sure? Seconds. Each second has, each minute has 60 seconds, and each. All right, 60 times 60, of course. And we can assign it to this hours active column that we wanted to create in our data frame. So let's do just that. And now if we look at hours active column in our data frame, you can see that it worked. And if we look at the data frame in general, you can see that we also have this hours active with correct values there. So what we'll do is we'll check if these hours active are correct, because it can be that someone put in a wrong value in there, and we can't detect it by checking is NA, but we can suspect that someone could have made a mistake while inputting these columns. So let's use how hours active dot the scribe method. If you remember, we used described before, and what it does, it returns simple statistics about whole data frame or a specific column, as we'll do here. And we'll transpose it to get this nicer view. If we don't transpose it, if you perform it on a series, it doesn't matter if you transpose it or not. So as you can see, the maximum value is some ridiculous number. It's about 50 years. Yeah, I think. Let's divide it by 365. Okay, it's in hours, so let's divide it by this times 24 hours. No, something's wrong. Yeah, 365. Okay, brackets, right, of course. 65 times 24 hours, and as you can see, it's 45 years. And let's just check for how long Kickstarter was there. Yeah, I already did that, but as you can see, Kickstarter launched in 2009. It was 11 years ago. So there's something definitely wrong with this data here. If it states that this project has been active for 45 years. So we have to do with those values something as well. What we can do is we can just view those columns by doing that, and let's view columns that were there that are active for more than 11 years. Yeah, is it clear? Because it may have been a little like too dynamic. We did the same thing that we did in the second ago, but we want to check for all values in our data frame that fall under this condition. So we'll take. Oh yes, sure, yeah, of course. Thank you. Yeah, let's just view the output, and as you can see, we have few values few records of our data frame that had the timestamp longer than this, and as you can see in the launched column, it has 1970 as a start or as a launch of this project. So we have to do something about this. Let's see how many rows are corrupted in this way. Only 7. So like the easiest way to do here is to just drop those values, because we have 400,000 records, and this is only 7 of them. So let's assign this. Let's call an index method again on this. I'll assign it to a variable over 11, let's call it, and now we can drop those values. Over 11 axis equals 0, and we want to do it in place. Let's check if it worked by checking this, and as you can see, it returned an empty data frame, so it worked. If we call df.arsActive describe again, we can see that the maximum value seems more realistic now. Yeah, so I think that our data should be clean at the moment. If you have any ideas how we could improve it, just let me know. And if at any point you know a more efficient or just a better way to perform the things I do, let me know as well. I'd like to learn something as well. Yeah, just last look, and I think it looks right. So let's ask the first question to this dataset. So now we will begin our let's call it analysis. The first question will be what is the average amount of money businesses need? To answer this question, we can just call a min function on a column that specifies the goal that they want to reach. This is this column. Where is it? Goal here. Oh, USD real goal would be better, because as you can see, there are different currencies in which Kickstarter gives us this data, and the person that shared this data frame was so nice to convert each of these different currencies into US dollars. So we'll use this column. We could also drop this goal column. Let's do it quickly. We got rid of this column because it brings no new value for us. I'll just copy this, not to write it. We can see this column, and we would like to take the average of this column, so let's just call method min. Now, as you can see, on average, businesses ask for 45,000 US dollars. What we would like to know, also the other question that we can ask, how does it differ between different categories? So firstly, let's explore this category and mine category columns. If we just specify category, it returns us this nonsense that we can't like understand at all, because there's 400,000 records. But Pandas has a method, I think it's series, but it doesn't matter. Unique. These are only the unique values of this column. And so, as you can see in this category, we have quite a lot of different categories, but there's also a main category column which is more specific, and not more specific, more general. publishing, films and video, music, food, design, art. Yeah, 15 different categories. That's enough for us. So now let's check what is the mean value, what is the mean amount of money asked by a business in each of these different categories, how it differs between these categories. To do so, we will have to group our data frame. We'll group by, and we want to group by. Group by is the method from Pandas to group our data frame, and we would like to do it with main category. And just to show you, now it only returns that it is a data frame group by object, another data object from the Pandas library. I think that we can extract some more information from it by doing this. Yeah, as you can see in this group by object, each record, we divided our data frame by each of these main categories. So the first, I broke this loop after first iteration, so we get only the first category, which is art. And maybe if I do this, no, it doesn't show in a nicer format. But it returns a key name first, as which is the name of the category, and then the whole data frame, which has art in the main category column. So we can perform operations on each of these values from that have art in the main category and each other category as well. So what we can do now is we can again do this. Take out the USD goal column from each of these grouped values and take a mean of it. And as you can see, it will return a mean in each of these categories. It's hard to analyze data in this way, so let's assign it to a variable. Let's call it main category, it doesn't matter. Now we have it in variable, and we can plot it. Pandas has the ability to plot values straight like from the pandas. But it's not really great. We use it only in this quick analysis. Usually we'll use external libraries to plot our data, and we'll get to plotting our data on the next meeting. So let's check what type is this. It should be a series, yes. It looks like a series, doesn't it? It has indexes and one value. So series has a method plot, and if we just do that, it'll do a line plot, and it's not informative at all as well. So what we want to specify a kind argument in this plot method and send it to bar. Bar plot would be good to visualize this data, and as you can see, with just this simple command, we were able to visualize this data. There are different arguments that plot takes, for example, color, and let's change to orange. And to make it even more visible, what is the difference in the money that companies need between these different categories, let's sort these values so that we have it in an descending way, or ascending if you will. The method that does it is sort values. we firstly sorted our values and then we plotted it. So as you can see, we have our data sorted. Sort values takes an argument ascending, and if we specify it to true, now our data is to false, sorry. Now our data will be sorted in an descending order. So as we could have expected, technology requires the most amount of money to found a project, and dance, for example, requires less. It's surprising for me that music only requires that amount of money, on average, obviously. I think that we answered this question in elaborate way, and we can move to another one. Now let's ask maybe something more complicated. What percentage of startups raise the amount of money they need? Yeah, to answer this question, we again need to look at what columns we have on our disposal. So to answer this question, we'll need USD pledged real column and USD goal real column, and check where pledged is more than a goal. So let's do just that. Where pledged column is greater or equal to goal column. And yeah, let's see the output. It only gives us true and false, but if we put it into if we put it into the data frame, it will give us all the values that all the businesses that met their goal. It is also in the state column as status. As you can see, each of them has a status successful. And we want to get the percentage of these, what percentage of startups raise the money they need. So we need to divide it by the length of it and multiply by 100 to get the percentage. Okay, we have to firstly we have to take the length of this as well, obviously. Yeah, and 36% of all startups raised the amount of money that they wanted to raise. That's a pretty high number. Now let's do the same thing by each category, again, like here. But yeah, so maybe let's specify the columns that we'll need. So we'll need this column for sure, this column for sure, and main category as well, because we want to check it by category. Now we can select df of calls, and we get only these three categories. We have to specify a list. We have to put like a list inside here. I'll show you what I mean. We can't get those columns by just doing that. because now data frame thinks that we give it 3 different arguments, but we don't give it 3 different arguments. We give it one argument which contains 3 different rows. So the first argument, we have to give a list if we want to specify more than one column. So we have these calls, and now what we need to do is want to group by our main category. And we will get again this group by object. And now we need to perform this mathematical operation on each row of this group by object. So as you remember, we used apply method to it, and now we'll write a function, not do it as a lambda because it will be a little longer. So let's call it foo, for example. I'm looking at the chat if there are any questions. If anything is not clear, interrupt me at any point. And this function will take a group as an argument, because we perform apply on groups, on each group individually. So let's do it like that. Let's assign the amount gathered to a variable, and needed to another variable. And now percentage would be the length of group of gathered that is greater or equal to needed. It is the same operation that we did here. We did this part so far. And now we need to divide it by length of this group. And maybe let's not multiply it by 100. Let's keep our percentages as values between 0 and 1, where 0 is 0% and 1 is 100%. And now let's return this percentage. And if we put this function into apply, it should be all we need. Yeah, great. So it returned us the percentage of companies that raised the amount of money they needed in each of these main categories. We can visualize it again. So maybe let's assign it to a variable. I don't know, let's just call it p, and now call p.plot. There's another method to plot a bar plot instead of a line plot. Instead of putting kind equals bar here, we can do it this way: plot.bar, and now plot it. Invalid syntax. Oh, there's an unneeded sign here. And as you can see, we get these percentages in each of the categories. Let's again maybe sort these values. Sort values. If you wonder why it's called sort values, is because we also have a method called sort indexes, and then we can sort by indexes instead of values. And what it tells us is that technology startups are the least successful ones, probably because they are often the least realistic ones, and thus gets their money gathered very often, like over 60% of the time. Let's not focus on this visualization again, because we'll use other better tools for visualization next week. What's next? I think that's all for this question. Maybe let's minimize those. And let's ask another one. Oh. Okay. Let's ask a question. Does success depend on category? And we'll take a look at this status column now, instead of performing it in this way. Now I can minimize it. So let's take a look at this state column. And again, let's only look at the unique values it takes. It takes so the outcome of the project can be failed, cancelled, successful, live, undefined, or suspended. That should be okay, but I want to show you another way in which we can use this apply method of Pandas. So what we'll do is we'll change these categories. We don't need that many of them. We'll just take fail, success, or undefined, or other, let's call it. So to do so, we need to have a function to put into apply method, and we'll define this function category convert. Yeah. Let it be, and it will take a state, individual state as an input. So if state in, let's say, failed or cancelled, let's treat this as the same thing and return failed. If successful or live, let's treat it again as the same thing, because if the project is live, let's say that it is successful. And else, return other. A good practice in Python is also to specify the type of input and type of output. It has been added in Python 3.8.5, I believe, and we can specify that we'll take Pandas series as an input, and we will return a string. Another good thing to write in Python is this docstring. It allows us to give information to other programs about what this function does. And let's write a short message. Modify state column, and it returns. Yeah, okay, let's leave it as it is. Let's not waste time on it. It's just the matter of good practice in a larger code, not necessarily in a analysis. So let's ignore it for the moment. And now let's replace the state column with our new categories. So we will apply our function, our category converter, on each row of the state column, and then assign it to state again. If we do that, and then see what are the unique values of the state column again, you will see that we have only 3 unique values: success, failed, success, or other. Maybe let's call it fail instead of failed if we call it success. Oh, now it performed it again on the already converted column. So that is why we saved the copy of our original data frame, so that we don't have to load in this data again. It is often that loading data can take a long time in Python with Pandas. So we save the copy of the original data frame and we'll run each of this again. Oh, I don't know. Okay, it's a small data set. Let's just run all the Jupyter cells once again. It's still running. It stopped here. Oh, okay, it's now doing this. And to avoid this situation, let's do this. Let's specify a new variable where we'll save a copy of our data frame. Copy. Okay. So we would like to see thus if success depends on a category. And the easiest way to do so, and the way that allows me to show you another Python method, is by bucketing these values. I think that's what it's called. Maybe not. Yeah. What we'll do is we'll create 3 new columns in our data frame, and instead of this one df.state column, we'll have 3 columns which have either 0 or 1 in them, dependent on the state column. You'll see what I mean in a second. Let's do it. getDummies is the function that we want to use. It takes a data frame and a columns argument, and the column that we want to use is state column. And as you can see, now we have 3 new columns in our data frame: state fail, state other, state success. And based on the value of the state column, we have different values in these 3 values. values, yeah. And it also deleted the original state column, so it was a good place to save our data frame. In this example, we can see only failed project, so and it also doesn't take the in place argument, so we have to assign it into our data frame to change it. And let's see if it works. So not only on the fail column. So let's take df.state success equals to 1. Let's see if such columns exist, and they do exist. Let's do the same with state other, and these ones exist as well, as you can see. So everything went well. This getDummies function allowed us to do this operation. It is very common that machine learning algorithms require this instead of categories. So it is an important function to remember. I think in scikit-learn, there's an equivalent to this function, and it is better, but we'll get to it when we will get to machine learning, probably in year 2021. Finally, 2020 is finished. Yeah, so let's again specify columns that we'll need to answer this question. Let's remind ourselves, because we did a lot of things after asking this question. Does success depend on the category? So we'll need state success column, state fail, and state other. Do we need anything else? Maybe the main category, right? Okay, these are the columns that we'll use to answer this question. Or maybe let's not give the main category column, and we'll do data frame group by. It worries me that there's no questions. Is everything clear? Sure it is. And those of you who've never programmed in Pandas before, because I cannot see those people saying that everything is clear. It's fine. If you don't understand anything, don't hesitate to ask me. There's only 12 of us, so it's great. Okay, so let's group by main category, and now let's take these columns let's take these columns, and as you can see, it returns data frame group by object again. But what we would like to do is we'd like to sum up all these values, because we have only zeros and ones there. So if we sum them up, we'll get the amount of projects that were successful, failed, or other for each category. And that is all the data that we need to answer this question. Does success depend on the category? We have it in a great form to do this. So let's assign it to a variable. I can't think of a good name. Let's just call it, I don't know, X then. Very creative. Okay, let's plot it and see what it gives us. As you can see, it gives us three these bars for each category, because there are 3 columns in the X variable. But this data is not very informative, because dependent on the category, there is a different amount of project in them. So we can't really compare these success rates where we don't have this data standardized, because it's obvious that even though like family and video may have a lower success rate than dance, it has way more rows, so these bars don't really represent the information that we wanted to retrieve. So let's create a new column in our x variable. As you can see, x is a data frame now. Yes, type. Yeah, x is a data frame because we called sum on this group by object. It turns then back into data frame then after we like modify this data in some way. And let's create a column total occurrences, and it will be x.sum and axis 1. So we'll sum each of these rows and assign it to total occurrences. So as you can see, this value plus this value plus this value returns this value. I had to specify axis equals 1 because if I didn't, first of all, it will probably it will raise an error because we will have only 3 values as a result of this operation here. We'll have the sum of this column, and this column, 3 values, and we have I don't know 10 or so categories. So it will fail. I can show you that. Oh no, it didn't fail. You just put none into them. But if we specify axis 1, we do it on each row. And we want to standardize it further, so let's maybe change those values into percentages, not values by themselves. Then we'll easily answer the question, does success depend on a category? Let's change each of these rows in columns variable. So this, and this one. Let's change it to x of these ones. Oh, nope. Of calls. And divide them. There is method diff to divide it. We could do it this way, but .diff comes from Numpy and it will be faster. And we want to divide it by total occurrences by this column, right? And again, we will not multiply it by 100. So let's see how it looks now. Oh, column must be same length as key. Oh, we have to specify axis equals to 0. Yes, because divide on the other hand has the default value of axis set to 1. Because that's why it's good to like specify axis in this kind of operations, not to or just do it twice and see. And as you can see, we now have percentages. So let's plot it now. Now it will be more informative. Oh, and we don't want to plot these total occurrences, so we'll use our ilog method to take rows, and we want all rows and all columns except the last one, because the last column is total occurrences. And as you can see, we have our plot. Maybe let's make it a little bigger because it's not that visible. I brought this browser on the left to show you the documentation of these functions as I use them, but I did not. So I don't know. Maybe we'll go through the documentation at the end. So the argument that allows us to make it bigger is fixed size. It's from the plot, and let's set and it expects a tuple, or I think list will work as well. So let's let's make it 10 by 5. and as you can see, it got bigger, and we can now actually extract some information from it. But maybe let's sort our values again. Sort values and ascending. Let's set it and maybe let's not sort them in descending way. Let's have it in ascending way. Okay, we have a few columns. So as you can, we have 3 different columns specified, and we want to sort values. And sort values function doesn't know what column to use, so we have to specify some to it. If we specify fail, then it will be sorted in a descending order in contrast to success. So maybe let's do it in ascending order. So there is our legend as well. Success rate. Dance has the highest success rate, and technology has the lowest success rate. That's like again the thing that we got to know from these other questions. And I believe it's all. If we think about this question, we basically did the same thing as we did here, but on a few, like a little bit different. So maybe let's see if we retrieve the same percentages from both of these methods of retrieving this information about success. So let's compare these columns. Yeah, so we want this x dot state success, because in the other one we only checked this one, and we want what was that? We assigned it into a p variable. So let's just print p. Yeah, great. These are the previous results, and these are the current results. We can already see that they differ a little bit. They differ. They must differ because we changed the state column. Maybe let's make it a little more visible. To do so, we can zip it. This and p. Oh, I'm copying one. And let's unpack it to a list. Now it's easy to compare those two numbers, but let's make it a little more visible, because I didn't show on the previous classes how to use this zip properly, I think. So maybe not properly, but efficiently. Let's do this. Let's print it for I and j in this zip, and let's assign it to some temporary variable. Yeah, and now we have it it's easier to read, and what we can do even further to even further improve the comparison by I. We could compare these values, like subtract this x state success from p, but let's just round them to the third number after comma with Python's built-in round function, and now we can easily compare these two results. and as you can see they differ, but not by a lot. So it was probably not the best idea to categorize them this way, because as you can see, or maybe it was, it's hard to say for me at the moment. But if we were to build a machine learning algorithm on this dataset, it would be good to not to reduce the dimension of these categories, which we did here. Okay, next question. If you have a question that we could ask to these datasets, don't hesitate to write it on the chat or just say it. But let's ask, does success depend on country? And let's see our country column and unique values of it. Okay, we have something like few different countries, but as you can see, there's this n, 0 country, which is probably the way that the author of this dataset said that that's a null value. We didn't see it before, but luckily we can see it now. So let's see how these new null values look. Let's select a data frame where data frame.country equals to this thing. And there's only 15 columns that lack the country value, the value in the country column. So I don't know if we should drop it, maybe not. Maybe just let's exclude those values. Let's take only the rows that doesn't have this value, but we will not change to Norway. Oh, it has oh yes, 3,800 rows, right? Yeah, 15 columns, obviously. Yeah, that's why I was wondering whether we should delete it or not. Maybe let's not delete it, but let's ignore these values while we check this, while we answer this question. So we just select those values that does not equal this, and let's call it country. Like, also I can, and this way, and let's group it right away. I wouldn't like to change it to Norway because this NO is probably null value, not Norway. I don't think that there's 4,000 projects from Norway, or maybe there are, but we can't make such assumption. It's better to make assumption that it is a new value than make an assumption that it is Norway while it may not be. Let's group by country, and let's again select these columns that we did here. And we don't have to copy this value because it's already in the copy this variable because it's already in the memory, but just to make the code more clear, let's do it. Columns, and let's sum it again. And let's see, what it has, and we have like exactly the same thing that we had before with different categories. We have it now with countries. Yeah. So again, we will need to divide it by the total occurrences. So let's again create the total occurrences. There's a comment on YouTube. Norway is already represented in the data frame by NO abbreviation. That's probably correct. So it's great that we didn't replace it with Norway, as somebody suggested on the Zoom chat. It doesn't matter. Okay, let's continue. Let's create a new column, total occurrences, and again we'll do country.sum and x is equal to 1. And as you can see, we have a new column, and let's now divide our columns by this new column to again have percentages instead of values, because as you can see, use has way more projects than other countries. Oh, it's tiring to talk for so long, for my throat mostly. Yeah, so let's assign to these columns again country of our columns divided by country total occurrences, and this time we remember to specify axis equals to 0. And let's see our country again. Maybe not in the same cell, it's a bad practice, which I continuously do. As you can see, now we have percentages as we wanted. And again, let's visualize it in the same way we did it before. So country, we have to select all rows except for these total occurrences for our visualization. Let's sort the values right away by fail this time and plot it as a bar chart, and change the figure size again. And we have this plot. Again, like plotting in Pandas is just a handy tool we have, but in general we use external libraries for plotting. I think this I think the Pandas uses matplotlib, which is the most popular plotting library in Python, which we'll get into details of in the next week. Not in the next week, because next week we'll have a special guest, but yeah, you'll learn more about it in a post soon. Facebook post, I mean. And as you can see, Italy has the worst success rate, and HK, I don't know what country is that, I'm not a geographist. Yeah, these are the results, basically. We can move on, or maybe I'll show you another type of plot that Pandas is capable of. It is a good example to make this plot on. We'll do a pie plot. So let's take one country only. Let's take US, for example. And now we use loc instead of iloc. So I can't do it like this. I can't do just -1 because iloc expects an integer. So we'll solve it by just giving the column names, like so, country.columns. Maybe let's firstly inspect what country.columns contain. And we want all of these columns except for the last one. So we can do it like that. And now we can plot pi because of this sign here. Yeah, great. Now we created a pie chart for just for as an example that we can do it as well. If you have any questions or ideas for a next question to our data frame, feel free to ask them. Maybe let's see how this date times works again. So how deadline affect the success rate? And hours active was our column. This is the time in minutes that in hours that certain project was active for. And I think the best way to visualize it is to do a box plot, but it wouldn't make sense to make a box plot right away of this hour active. We have to group it by success rate. But the box plot method actually expects us to group it in a way, and we can specify column. Our column would be hours active, and by and state success. And now we'll have a box plot which will give us a lot of information, and mostly probably some it's not loading. Oof. Oh, great, here it is. As you can see, mostly we get outliers because this hours active takes very wide range of values. So it may not be the best metric, the best statistic to look at the moment, to assess this. So let's maybe just look at means instead. Yeah, means or medians, what do you think? Do you want we want to include these outliers, so the better metric is is a mean, definitely mean. So let's do that. df dot group by maybe this success that sum, and we want only maybe not group it, but just take it right away. State success equal to 1, and now take hours active dot mean. And let's do the same for states for failed or other projects. You can see these means don't differ a lot, and now we could like do a p-value analysis and with power analysis to determine whether they come from the same distribution or not, but it's out of the scope of this this meeting, so yeah, let's leave it as it is. From the box plot, it doesn't look like they come from the same distribution, but we'll have to perform like p-value test or whatever. Yeah. I think that's all that I wanted to show you with this data set. Maybe let's look at this documentation now for a second. Do you have any questions? Not get started guide. Maybe let's like oh, there's one more method that I wanted to show you in Python in Pandas that is useful. We don't have to change these categories as I did it. Oh, it's lagging a little. There's lots like this. There's a okay, there's a question. Just 1 second. We don't have to categorize our variable in this way because we could also state like some mathematical greater than or something like that to change the values of numerical columns. Like let's take what was the column that had numbers in them? USD goal. Let's take this column and let's imagine that we would like to like group it. The function that does it in Pandas is qcat. The q comes from quantiles. There's also just cat function. You can check their documentations. And we want to divide this into 5 different intervals. And as you can see now, df.dsd goal real got like cut into 5 categories, where 5 intervals like these intervals here, and each one is greater than the other one. And we can, there's a argument, I think it's labels, that we can specify to give like different values here than this. Maybe just let's label them by numbers from 0 to 5. Yeah. Okay, now question. I have a question. How to transform to date type in Pandas? I was trying to get the row that has, but string method doesn't have. Yeah, because string methods doesn't have as type method. You wanted to do something like this, right? This is just a Python string, so it doesn't have such fancy method as type. What you can do is you can put it into numpy.datetime64 and now give it this string over here. It should change it into datetime object. And how to do it in Pandas? Oh, I didn't show you how to create a data frame. So it's a good occasion to do so. We can create data frames by giving a dictionary. There's a couple different methods, but dictionaries are usually the easiest ones. So let's give it date, and normally we would give it an array, but maybe let's do it. We have this, second, and third, for example. We have our data frame. Let's assign it to df1, for example. And df1.asType date times 64. Yeah, it changed the types. It throws an error. KS is our data frame, but what error does it throw? KS launched. Maybe you didn't change the types of KS, because it looks like it should work. Yeah, it works for me. It shouldn't throw. If I do it on the not like transformed data frame, it probably throws an error, because yeah, no supported between instances of Numpy array and string, and this is because the type of not this thing. The type of again, the type of case.launch. I have to is and yeah, let's specify 0 is a string, as you can see. This is why it doesn't work. But at the beginning of our notebook, I changed it from a string to a appropriate data type over here in these two cells. Okay, nice. I didn't change it. Yeah. So no problem. Thanks for the question. I think that I'll wrap it up here. If you have any more questions, I can still answer them. And I will send you this notebook if you like, but I don't know where should I do it. We have a Discord channel, so maybe it's a good opportunity to invite you all there, because you can also ask me questions, or ask like all of the whole community questions about different areas of data science, and I and probably a few more people will be happy to answer them. And I will send you this notebook on the Discord server. My Discord is updating at the moment, so just 1 second, because I need to copy the invitation link so that you can join it. So next week we'll have a guest again, and in 2 weeks, I think it's 22nd of December, so we probably won't have this meeting, but I'll be back with you in the new year, I guess. It looks like 5th is Tuesday. So I think that we'll see each other on the 5th. Are you using VS Code pre-release only, or is there anything else that makes the Jupyter Notebook in VS Code so different? I think that it's the Python extension that adds the ability of the Jupyter Notebook to work with. It's the Python extension from Microsoft that allows VS Code to run Jupyter Notebooks in it. And this new release version only this pre-release version only changes the look of this Jupyter Notebook. I can still open it in the way it used to work. Look like. Oh, I have to close it first, and this is what you'll get in a regular Visual Studio Code. As you can see, it loads for a few minutes, it starts the kernel, etc., and only after like 15 seconds or so it's opened, and it looks a bit different. It doesn't work with WSL. It has this weird background, etc. There's basically lots of problems with this old version. In pre-release they changed it to a more to better one. Yes, the invitation. No problem. Invite people. Oh no, that's not the link. I paste the link to the Discord server on the chat and on the YouTube chat as well. And yeah, I'll give you the notebook there. So thank you very much for coming. I hope that you learned something, and I hope that you'll join me again when we learn how to visualize data and probably do machine learning next. And yeah, thank you very much. Have a great week. Bye.